What if electricity could fall from the sky, literally? Japan is about to launch a satellite that will beam solar power from space directly to Earth. A power station that never sees clouds, never experiences night, and beams clean energy directly to the ground. For decades, this idea sounded like pure science fiction. But in 2026, Japan plans to test it for real. This is the OHISAMA project, and it could change how humanity powers its future. Solar energy is one of the cleanest power sources we have, but it has a major weakness. Solar panels only work during the day, clouds reduce their output, and entire countries lose solar power every night. This makes solar power intermittent, not continuous. To run modern civilization, we need baseload energy, electricity that flows 24 hours a day. So what if we simply moved solar power above the atmosphere? In space, the sun shines almost all the time. There are no clouds, no storms, and no night cycles like on Earth. Solar panels in orbit can receive much stronger sunlight, up to 13 times more energy than panels on the ground. This concept is called space-based solar power, or SBSP, and Japan is now preparing one of the most ambitious experiments ever attempted. The project is called OHISAMA. The mission will launch a 180-kilogram satellite into low Earth orbit, about 400 kilometers above Earth. The satellite carries deployable solar panels covering about 2 square meters. Once in orbit, these panels capture sunlight and convert it into electricity. But instead of storing the energy, the satellite will beam it back to Earth. Here's how it works. First, the satellite collects solar energy using photovoltaic panels. Next, onboard electronics convert that electricity into microwave energy. Then the satellite wirelessly transmits the microwaves toward Earth. On the ground, a receiving station in Suwa, Japan, captures the beam using a network of antennas. Those antennas convert the microwave signal back into electricity. The goal of this test mission is modest, delivering about 1 kilowatt of power. That's roughly enough to run a household appliance. But the real goal is proving the technology works. For decades, space solar power was considered too expensive. Launching huge structures into orbit cost billions of dollars. But the space industry has changed dramatically. New reusable rockets, like Starship from SpaceX, could launch massive infrastructure far more cheaply than before. At the same time, engineers are developing an inflatable solar arrays that expand in space. Ultra-lightweight power electronics. Precision beam steering systems. These technologies allow solar power stations to be lighter, cheaper, and more efficient. The OHISAMA mission is only the first step. Japan's long-term goal is far more ambitious. By 2040, researchers hope to build gigawatt-scale orbital solar farms. A single space power station could generate 1 gigawatt of electricity, enough to power an entire city. And Japan is not alone. In 2023, Caltech in the United States successfully transmitted power in space using the MAPLE experiment. Meanwhile, China's Omega project is designing kilometer-wide solar arrays in geostationary orbit, 36,000 kilometers above Earth. The global race for space solar power has already begun. If these technologies succeed, the future of energy could be transformed. Instead of relying only on power plants on Earth, humanity might build power plants in space, harvesting sunlight where it shines brightest and sending clean energy back to the planet below. A constant stream of power from the sun, delivered from orbit. And it all begins with a 180-kilogram satellite called OHISAMA. Follow us for more.